Consider this situation. Let's say there's a person of mass capital M standing on a boat of mass small m. Initially, the system is at rest. Okay. Tell me, is it possible for the person to walk forward on the boat or not? Can the person walk forward on the boat or not? Like in a real life situation, is walking possible on a boat or not?
Yes, sir.
It is possible. Okay. So let's say the system is at rest initially. Person along with the boat are not moving. Now, if the person starts walking with a speed v, okay, person assumes starts walking towards right. Tell me, should there be any force acting on the person while walking or not? Which force helps the person walk forward? Anyone? Which force helps the person walk forward?
Friction.
Friction. Okay. Now, if the person starts walking forward, in which direction does friction act on the person? If the person starts walking forward, in which direction does friction act on the person?
Forward, sir.
Forward itself. Okay. Person's foot will tend to slide backward. So friction on the person's foot will act forward. So you can imagine something like this. And what exerts friction on the person's foot? What exerts friction on the person's foot?
The boat, sir.
The boat, the floor of the boat. Okay. So on the person, friction will act forward. The same friction will act on the boat in the backward direction. Action, reaction. Okay. Assume water does not offer any friction. Okay. Means the boat can freely slide on water. Now, if this person starts walking forward, on the person's foot, the friction will be forward. On the boat, there will be friction in the backward direction. Okay. So imagine the person started walking forward. What happens to the boat? Does it stay there itself? Does it move back? Does it move front? What happens to the boat as the person walks forward? Anyone?
The boat moves backwards, sir.
The boat moves backward because there is friction acting on it in the backward direction. Okay. So initially the person was here and okay, the left end of the boat was here. Okay. As the person walks forward, okay, friction is needed for the person to walk forward. The same friction is acting on the boat in the backward direction. So what happens as the person walks forward? The boat will move in the backward direction. This is what actually happens. Is this clear to all of you? How the system is moving? The person who was originally here has now moved forward. And the boat, which was originally the left end of the boat, which was originally here, has moved backward. Fine. All this is happening due to friction. Now, for the person, friction is coming from the boat, it's an external force. For the boat, friction is coming from the person, it's an external force. But if you take person plus boat as one system, you all tell me what all forces act on this person plus boat system. Friction is there, it's an internal force. What external forces act on the person plus boat system?
Wait, sir.
Their weights will be acting. They're in the vertical direction. And there will be a supporting force from the water. Okay, you can call it normal force. It's actually called buoyant force. That force will also be there, but that will also be vertical. Okay, so their weights will be acting and there will be a buoyant force from water. All those are in the vertical direction. Are there any horizontal external forces? Are there any horizontal external forces?
Sir,
There are.
flow of the river.
It's not river. Okay, it is. It is a lake. Okay, water is not flowing. Fine. So when water is not flowing, there is no horizontal external force acting. Friction is internal force. Therefore, we can say that the net force in the horizontal direction is zero. On what? On the person plus boat system, the net horizontal force is zero. Okay. And if net force is zero, linear momentum is conserved. Okay. So the question is, if the person starts walking with a speed v, what is the speed of the boat? Okay. Try this, all of you. If the person starts walking with a speed v, what is the speed of the boat? Any answer, anyone? We know the speed with which the person is walking. You need to find out the speed of the boat. Okay, Vanilla, your answer is correct only. Pawan, tell me, how are you trying to solve this?
Sir, ideal example.
We have discussed the idea, no? We found that the net force on this system is 0. Listen, all of you. Pawan, you tell me, if net force on a system is 0, which principle of physics can be applied? If net force is 0, what can be applied?
Sir, and opposite force is equal now.
Equal and opposite forces are there. So net force is 0. If net force is 0, what equations can we write? What have we done in the last class? Okay, anyone? If net force is 0 on a system, what principle can we apply to that system?
Conservation of linear momentum.
Conservation of linear momentum. That means total initial momentum of the system will be equal to final momentum of the system. Now, why is this useful in this case? Because you know speed of one part of the system and you need speed of another part of the system. Momentum equation includes velocities. No, from that you can get the speed. Okay, so remember this, all of you. Yesterday or last class, we discussed cases of collisions. One block going and dashing with another block, two carom coins, such things. So those were cases where the motion of one object disturbs the motion of another object. Those are clear cases of collisions. Here also, initially the entire system was at rest. Because the person is moving, the boat has started moving. Right? So here also, motion of one part of the system is disturbing the motion of another part of the system. In such cases, you should check if linear momentum conservation is applicable. You should check if net force is 0. If it is 0, you can write equations and find out some things about that system. So here, because the person started walking only, the boat started moving backward. In such cases, you can apply conservation of linear momentum. And the question is particularly asking you, what is the speed of the boat after the person starts walking? So you need an equation which involves speeds or velocities, and linear momentum equation will involve velocities. Okay. So initially system is at rest, that is given in the question. What is the system? Person plus boat is the system for us. So Pawan, tell me, if person and boat are both at rest initially, what is the total initial momentum of the system?
Sir, 0.
Person's momentum is 0, the boat's momentum is also 0. Both were at rest initially. Mass into velocity, both initial velocities were zeros. So initial momentum is 0. Finally, the person has momentum in the forward direction, that is positive momentum. The boat has momentum in the backward direction, that is negative momentum. That way the final momentum also remains 0. Okay. So they must have been having equal and opposite linear momentum. We'll write an equation based on that. Yusuf, tell me, the person's mass is capital M and the person moves with a velocity v relative to ground. So what is the final momentum of the person? Person's mass is capital M. Person moves with a velocity v in the forward direction. What is the final momentum of the person? Anyone? Okay, yeah, Yusuf, if you can unmute and tell. Okay, anyone else?
The mass into velocity.
Okay. You can write it as mv I cap. V is the speed with which the person is moving. Direction is forward. So mv I cap, that's the final momentum of the person. Then that of the boat. Boat's mass is small m. We don't know its velocity. Let's call it v dash and leave it like that. See, we know that it's in the backward direction, but the equation will tell you the direction anyway. If you write a vector equation, you will get the direction automatically. Just call the velocity as v dash. Okay. Now in this situation, linear momentum is conserved. So initial momentum of the system, which was 0, should be equal to final momentum. So we can say that capital mv I cap plus small mv dash should be equal to 0. Therefore, small mv dash is equal to minus capital M v I cap. Therefore, v dash, the velocity of the boat, will be minus capital M by small m v I cap. So as I said, the answer is in the answer you have minus I cap, means it indicates, means the velocity is towards left. Okay. So if you only want the speed of the boat, speed is magnitude of velocity, it will be capital M v by small m. That's the speed with which the boat moves in the backward direction. Is this clear to all of you? This is a situation where, because of the motion of one part of the system, the motion of another part of the system has been disturbed. Because the person moves forward only, the boat moves backward. Okay. In any such situation, you will check if the net force is 0 or not. And if it is 0, you will apply linear momentum conservation to solve the problems. Okay. Let's try one more question based on the same situation. Okay. You have visualized friction and all. You know that initial momentum will be 0. Right. System is initially at rest again. This time let us assign some masses. Let's say person's mass is, okay, 50 kg. Assume the boat's mass is some 20 kg. It's made of very light wood. So boat mass is 20 kg. Okay. If the person walks with a speed, let's say 2 meters per second, relative to the boat. So that 2 meter per second is not with respect to ground. When the person starts walking, the boat also starts moving. You all know that already. When both of them are moving, the speed of the person relative to the boat is 2 meters per second. Okay. Calculate the actual speeds. Actual means with respect to ground of the person and the boat. Okay. So we don't know the speed of the person, original speed of the person. We don't know the original speed of the boat also. We know that if person starts walking forward, boat will move backward. That much we know from conservation of linear momentum. So if the relative speed with which the person is walking is 2 meters per second, calculate the actual speed. Solve it carefully, all of you. Aishwarya, can you unmute and tell how you are trying to solve the problem?
Sir, yes, sir.
How are you trying to solve it?
Sir, so the velocity of person minus velocity of boat is 2 meter per second.
Okay. So what she has done is velocity of person with respect to boat. That is velocity of person minus velocity of boat is 2 meters per second. Correct. That is one equation. And the other equation?
Sir, I have substituted the value of boat as 50 by 20 V, sir.
Okay. 50 by 20 you got from momentum conservation. So you should say the other equation is linear momentum conservation equation. Okay. What answers did you get?
Sir, I've got a quadratic equation. I'm solving it.
How will you get quadratic? What is the substitution you said? Velocity of boat?
5 by 2 V.
5 by 2. V is velocity of person only, no? What else could V be? V is velocity of person. So if you put this here, why will the equation become quadratic?
Sir, I think I made a mistake. I'll check it again.
Check it once. It will not become quadratic. Okay. Listen, all of you. Yeah, that is a good way to solve. Person walks with a speed 2 meters per second relative to the boat. Okay. Now, person is walking in the forward direction. Forward direction is I cap. Okay. So speed is 2 meters per second. Speed is magnitude of velocity. Assign a direction to it, it becomes velocity. So you can say that velocity of person with respect to boat is 2I cap. Okay. Now, by definition of relative velocity, you can call this as velocity of person minus velocity of boat. Listen, there is one equation with which, at which students go wrong usually. Like in this case, we know that if person moves forward, the boat moves backward. We already know that. So what students tend to do is they tend to take person speed v1, boat speed v2. While writing in the equations, they won't know whether they should take minus v2 or simply v2. Okay, that is what confuses most students. Listen. Suppose, okay, like we know the directions in which they are moving already. Assume you don't know the directions. Take both of them in the forward direction. Okay. So what I mean to say is take velocity of the person as v1 I cap. Velocity of the person v1 I cap. And take velocity of the boat as v2 I cap. If boat is actually going in the backward direction, you will get a negative answer for v2 that will take care of it. Okay, so assume both are going in the same direction and write equations. If any of them is actually going in the opposite direction, you will get a negative answer for that. So velocity of person minus velocity of boat. Velocity of person will write v1 I cap minus velocity of boat is v2 I cap. So now if you remove the I caps, you can write 2 is equal to v1 minus v2. That is one equation. And the other equation is that for this system, we know linear momentum is conserved. Initially, boat and person were both at rest. That means initially the total momentum is 0 is equal to final momentum. Finally, the person, 50 kg person, is moving with a velocity v1 I cap. So person's momentum will be 50 v1 I cap. And the boat's mass is 20 kg. Its velocity is v2 I cap. So its momentum becomes 20 v2 I cap. So you can say that 50 v1 plus 20 v2 is 0. That means 5 v1 plus 2 v2 is 0. This is the second equation for us. And there are two unknowns, v1 and v2, velocity of person and velocity of boat. Okay. So from the first equation, we can say that V1 is 2 plus V2. Okay. We'll take this and substitute here. Then it becomes 5 into 2 plus V2 plus 2V2 is equal to 0. 5 into 2 is 10 plus 5V2 plus 2V2 is plus 7V2 is equal to 0. We are getting V2 as minus 10 by 7 meters per second. And as expected, we got a minus sign for V2 because we knew the boat was going in the backward direction. Okay. And then you can solve for V1. V1 is 2 plus V2. V2 is minus 10 by 7. If you do this, 7 into 2, 14 minus 10 becomes 4 by 7 meters per second. And we got a positive answer for V1. Okay, as expected. Person is going in the positive direction with a velocity V1 4 by 7 meters per second. Boat is going in the backward direction with minus 10 by 7 meters per second. So here we know when person moves forward, the boat moves backward, but we took both their velocities in the forward direction as V1 I cap and V2 I cap. See, these are the important things that you need to learn because that is where you will get stuck while solving problems in the exam. Okay. So assume both objects to be moving in the same direction. The equations will tell you the correct direction anyway, finally. So any doubts in the solution? One equation was the relative velocity equation. The other equation was the momentum conservation equation. Okay. Next question. Let's consider this situation, gun firing a bullet. Assume there's a gun of mass capital M which fires a bullet of mass small m. Before firing, the gun and bullet would both have been at rest. Okay, in the person's hand, the person whoever is holding the gun. Initially, both were at rest, assume. Now the bullet is fired. First case. Okay, the question is to calculate the recoil speed of the gun. Can any of you tell me what we mean by recoil of a gun? Many of you might have played those first person shooter games, PUBG, Counter-Strike, whatever. Usually when you fire that rifle, no, bullet goes forward, okay, but the rifle kind of, what do you say? It gets pushed in the backward direction. Yes or no? Have you all observed this or not? It's just like that balloon and air case. Okay. So if air molecules leave the balloon on one side, the rest of the balloon moves in the opposite direction. Here also, see the firing of a bullet. Can any of you tell me how a bullet is fired? How does it get that speed? Pawan, what happens? What happens inside the gun? Huh?
Sir, కొన్ని chemicals ని burn చేసి దానిలో pressure create చేసి push చేయమని చేయడం.
Yeah. So in an actual gun, that is what happens. A small kind of an explosion happens inside the gun. Okay, when the trigger is pulled, a chemical gets ignited. Okay, it kind of explodes and pushes the bullet in one direction. But when it pushes the bullet in one direction, it will automatically push the gun in the backward direction also. That will also be there. That's why the gun has to be held very firmly. Or see, you might have seen some toy guns which are like based on a spring. There'll be a compressed spring inside the gun. When you pull the trigger, the spring relaxes. Immediately it comes, I mean, it relaxes. Then what happens? It pushes the toy bullet in the forward direction. But when a spring relaxes, it pushes the gun also in the backward direction. Okay. So basically, the firing of a bullet, whether it is by using chemicals or by using springs, okay, it involves an action reaction pair. Inside the gun, a force acts on the bullet in the forward direction and an equal force acts on the gun in the backward direction. Gun, rifle, whatever it is, pistol. Okay, it is based on an action reaction pair. And in this system, like if you consider gun plus bullet as one system, whatever force fires the bullet is an internal force. Okay, so we consider external force to be 0 and the net force to be 0 for the gun plus bullet system. Of course, the person holding the gun will have to exert a force while firing, but we will ignore that. If that force is not exerted, the gun will recoil in the backward direction. Okay, that is what we are working on. So I assume there is no force exerted on the gun to prevent recoil. Fine. Okay. So if net force is 0, linear momentum conservation is applicable. Before firing, both gun and bullet, you assume they were at rest. Okay. The question is to calculate recoil speed of the gun, but I'll give you two situations. First case, when the bullet is fired with a speed v. Okay, let this be part of the question. When the bullet is fired with a speed v, first question with respect to ground. Second question with respect to the gun. Okay, so basically you are given two different situations. In the first situation, the actual speed of the bullet itself is v. With respect to ground, it is moving with a speed v. Then you find out the speed of recoil of the gun. In the second situation, the actual speed of the bullet is not v. We don't know the actual speed. Okay, bullet is fired, bullet will be moving, and gun will also be moving. The relative speed of bullet is given v in the second question. Okay, so solve the first part, all of you. Gun's mass is capital M, bullet's mass is small m. Initially, bullet and gun were both at rest. Okay, Vanilla, your answer is correct only. Yusuf, any answer to the first part? Okay, Pawan.
Sir, minus small m v by capital M.
Okay, minus indicates the backward direction, small m v by capital M, correct. See, when you know the bullet's velocity with respect to ground, you can directly use it in linear momentum conservation. Listen, why the reference frame matters also you understand. With respect to ground, the forces acting on the gun and bullet are these. Some forward force acts on the bullet, backward force acts on the gun. Net force is 0. Okay, and if net force is 0, linear momentum can be conserved. So with respect to ground, conserving linear momentum is reasonable. Second part of the question was, bullet speed is v with respect to the gun. Now the gun here is not an inertial frame. Why? Before firing, the gun was at rest. After firing, the gun has recoil velocity. Means in the process of firing, the gun has accelerated. Okay. And accelerated frames are called non-inertial frames. And when applying Newton's laws from such frames, you need to consider a pseudo force. Okay. So you'll have to do all that. You'll have to consider pseudo force on the bullet, which will be an unbalanced force. Okay. On the system, if you see. So with respect to gun, you can't apply momentum conservation, linear momentum. Only with respect to ground, you can. Okay. So in the first case, the bullet's velocity is already given with respect to ground. So you can use it as it is in the momentum conservation equation. Remember, momentum is conserved. Linear momentum is conserved for the gun plus bullet system with respect to ground only, not with respect to gun. Okay. So simple momentum conservation, if we write, initially both gun and bullet were at rest. So gun's momentum 0, bullet's momentum 0 is equal to, finally, after firing, the bullet has a velocity v in the forward direction. So its momentum becomes mv I cap. Gun has some other velocity we don't know. Let's call it v dash. Gun's mass is capital M. Velocity, let's call it v dash. The direction will be minus I cap, but the equation will give you the direction anyway. That's all. Therefore, capital M v dash becomes minus small mv I cap. That means v dash, the velocity of the gun after firing, which is what we call as recoil velocity, is minus small mv by capital M I cap. The minus I cap indicates it's in the backward direction. The speed is small mv by capital M. Okay, Yusuf, is this clear? Right. That's the speed with which the gun recoils. Practically, if you see, like the mass of the bullet is very small compared to the mass of the gun. Okay. So this ratio small m by capital M, mass of bullet to mass of the gun, it will be a small ratio. You multiply that with the speed v. This speed will not be as high as that of the bullet. It will be very small compared to that of the bullet. Okay. And the person holding the gun will be able to control that speed. Okay. That's why recoil of a gun is not so harmful, but yes, to some extent it is harmful. If you have to prevent, I mean, you have to exert enough force to overcome that recoil velocity. So the gun has to be held firmly. Otherwise, due to that recoil, the person who is shooting also could get hurt. That possibility is there. Anyway, so that is what is the recoil velocity of the gun when you know the speed of the bullet with respect to ground. Now the second case. Bullet moves with a speed v relative to the gun in the second case. So we don't know their actual velocities. We don't know the bullet's actual velocity. We don't know the gun's actual velocity. So what we are going to do is, we'll assume bullet's velocity is v1 I cap, forward direction. And I'll assume gun's velocity is v2. That also I'll take in the forward direction. I'll get a negative answer. Okay. But taking both in the same direction has a lot of advantages. It makes writing the equation very easy. Okay. So let's take them as v1 and v2. Or I should say v1 I cap, v2 I cap. Okay. Now the question is saying that the bullet is fired with a speed v relative to the gun with respect to gun. If relative speed is v, the relative velocity of bullet with respect to gun becomes vi cap. Speed along with the direction becomes velocity. Okay, so vi cap is the velocity, and we can write it as velocity of bullet, actual velocity of bullet minus actual velocity of the gun. Actual velocity of bullet, we took it as v1 I cap. Velocity of gun was taken as v2 I cap. Subtract them. So we can say that v is equal to v1 minus v2. That's the first equation. Can one of you tell me the other equation? Relative velocity, we made use of it. What is the other concept that is applicable in gun firing a bullet? What physics principle is applicable in gun firing a bullet?
The linear momentum.
Linear momentum conservation. Okay. Initially, gun and bullet were both at rest, so initial momentum is 0. Finally, bullet moves with a speed v1 I cap, velocity v1 I cap, and gun moves with a velocity v2 I cap. So this will be the final momentum of the system. So you can say that small m v1 plus capital M v2 is equal to 0. I just removed the I cap part. This is the second equation. You need to solve the two equations. You will get v1 and v2. Okay. So solving means you can get v1 from the first equation and put it in the second equation. You'll have an entire equation in terms of v2 and you can get it. Once you know v2, you can get v1 also. Okay. The complete solution you do later and send me the answers. Did you all understand the idea? And questions like this are very common based on momentum conservation. They can give you the actual velocities or they can give you relative velocities and expect you to solve. Okay. Next, suppose there is a shell or basically a bomb. Assume its mass is 5m initially at rest. Okay. Let's assume it explodes. Now see, a shell or a bomb exploding happens due to internal forces. The chemical inside gets ignited and it exerts force. Okay, like basically the gas has to expand. Whatever chemical is in solid form gets converted to gaseous form. A lot of energy will be released. So that will push fragments or parts of the bomb in different directions. So it happens due to internal force. So remember, explosion happens due to internal forces. Now, internal forces will never contribute to the net force on a system. We had discussed this before. Because internal force will have the reaction also inside the system itself. So if action reaction are both within the system, then on the entire system, their net effect will be 0. Okay, so let's say this 5m bomb of mass 5m explodes into 3 different fragments. It explodes into 3 different fragments this way. You can consider them like this. Three different fragments of masses m, 2m, and 2m. Okay. The fragment of mass m, let's say it flies off to the left. with a speed v. That is given to you in the question. And one fragment of mass 2m, let's say the one which is on the lower side, assume it goes this way. This also with a speed v. Okay. Find out how the third fragment moves. So calculate speed of the third fragment. After explosion. Try this, all of you. I got one answer for speed as v root 5 divided by 2. Another answer I got velocity. Okay. Pawan, in your answer you can cancel m. Okay, listen all of you. Bomb initially at rest explodes, and as I said, explosion happens due to internal forces. Internal forces never contribute to the net force on a system. That means during the explosion, the net force on this bomb system of 3 fragments is 0. And if net force is 0, linear momentum is conserved. Initial linear momentum, since the bomb was at rest, is 0. Finally, 2 fragments velocities we know. We have to find out the third fragment's velocity. You can write the final momentum like this. This part of mass m is moving with a velocity v to the left. So its momentum can be taken as minus mv I cap. The other part of mass 2m, its velocity is v in the downward direction. So its momentum can be taken as minus 2mv. Okay, mass is 2m, velocity is v, direction is minus j cap. And the third fragment, its mass is 2m. We don't know its velocity. That's all. This is the final momentum of the system. And we know this should be equal to the initial momentum, which is 0. Simply readjusting this equation will give you the velocity of the third fragment. Okay, m can be cancelled in this equation. You get velocity of the third fragment, v dash, is equal to, these minuses go to the other side, they become plus vi cap plus 2v j cap. That's the velocity of the third fragment. And if you want speed, speed is magnitude of velocity. That is square root of x component squared plus y component squared. So, okay, wait, 2v dash, no? This becomes v root 5. So v dash, the speed of the third fragment, is v root 5 divided by 2. Correct. Okay, but see, in the exam, they won't tell you that explosion happens due to internal forces, so you conserve linear momentum. All that you have to think on your own. Okay, how do you get that idea? They said something is happening to a system and they ask one velocity of one part of the system. In such cases, you have to get that idea that maybe linear momentum is conserved. Okay. Fine, we'll stop it here for today because I have some other work actually. Next class, we will discuss forces involved in circular motion. Okay. How to write force equation when an object is moving in a curved path. Now, yesterday I had sent one worksheet. Solve the question. Nobody has sent answers to that. Do it. Tomorrow also you will get one worksheet based on momentum conservation itself. And in tomorrow's worksheet, there will be one section on rocket propulsion. Okay. If a rocket releases exhaust gas at a particular rate, at what rate the rocket's body will accelerate forward? That derivation will be there in tomorrow's worksheet. You do that on your own. And the class after that we'll discuss. Okay, if you have any doubts, you can ask. Otherwise, we'll close this session here. So today we just solved problems based on momentum conservation.